Okay, hi everyone, and we're Group 22, and welcome to our demo of our app, which is called Next Up, and it's a universal virtual queuing system. I'm Anna, and I'm joined by my teammates Victoria, Stephanie, and Manu. So Next Up is a free platform that lets venues, so restaurants, bars, or retail stores, manage wait times and their capacity digitally, and also lets customers join their queues remotely from their phones without ever having to actually physically show up to hold their place in line. So our two main stakeholders are venues and customers. And on the venue side, venue staff can open or close their venue. They can pop people at the front of the queue to let them into the venue, and they can adjust predicted wait times. And on the customer side, users can browse current and predicted wait times across multiple different venues all in one place, and they can add themselves to a queue without physically being present at the venue. So our app, Next Up, differs from some competitors that we did market research on, such as Waitlist.me or OpenTable, in a few different ways. So those apps are either restaurant specific or they charge a monthly fee for venues to use. Whereas our app, Next Up, is universal. So there's one platform with many different venues, and it's also free for all venues to use. So it benefits customers because they don't need a separate app for every restaurant, and it benefits venues because there's no subscription fee as like a barrier to adoption for them. So our target users include people who face barriers to standing in physical lines. So that could be people with mobility impairments, chronic pain, or just anxiety from standing in crowded spaces. So for those users, um, it benefits all users because there's like a convenience aspect, but for these users specifically, it opens up access to places and experiences that might otherwise not be accessible to them at all. And overall, we really had accessibility in mind when we were designing our app. So now we'll walk through what the app actually does through a few different personas.
Great. We're going to walk through the app from the perspective of two personas. First, we'll do Shelly, who's a customer, and then Priya, who's a hostess. So Shelly is a customer and recovering from a knee injury. It's a Friday night and she wants to grab dinner, but she knows every restaurant in downtown Ann Arbor is going to have a line out the door. Normally, that would mean she would just go home and order delivery, since she can't stand for long periods of time due to her knee injury, but instead she can use Next Up. She first visits our homepage, and right away she can see a list of nearby venues, each one showing the number of people currently in the queue and the estimated wait time. First, Shelly needs to decide where she wants to eat. She can use the search feature to find the queue details for specific restaurants. Zingerman's is nearby with several people already in the queue. She taps on it to get more details. The venue detail screen shows her the full picture, including the current queue length, estimated wait, and a green Join Queue button. She taps it. A yellow bar appears telling her position in the queue once she joins. She confirms. Now, instead of standing outside Zingerman's on her crutches, she's sitting in her own car down the street. She navigates to the My Queue tab using the bottom navigation bar. Here she can see she's in Zingerman's queue, her current position, how many people are ahead of her, and her estimated wait time. Everything she needs in one place. But then she changes her mind. Maybe she's not actually that hungry yet and wants to come back later. She'll then tap Leave Queue. A confirmation dialog appears saying, yes, leave queue. She confirms it, and her My Queue screen updates to say she's currently not in any queue, with instructions on how to rejoin. When she goes back to the venues tab, she sees Zingerman's queue still open and decides to rejoin a little later when she's ready. She taps join queue again, gets a new position, and she's back in. That's Shelly's story. She browsed the venue, joined a queue, left, and rejoined, all without standing up once. Now we'll switch to the venue side. Priya is a hostess at Zingerman's. It's Friday night, the deli is packed, and she's managing the door. She has Next Up open on the tablet on the host stand. The venue dashboard shows her everything at a glance: number of guests currently in the queue, the current estimated wait time, and how many guests have been served tonight. She has a queue tab open showing the full roster, every person waiting, their position, their party size, and when they join. She can tap on any name to pull up more detail about that party. The detail modal shows her the customer's name, position, party size, and join time. If someone calls in and says they want to be removed, Priya can remove them anytime from this screen. Now the next party to be served in the queue walks through the door. Priya taps Serve Next Guest. The queue count drops by 1, the estimated wait time updates, and the guest serve counter increments. Now Shelly's customer side. Her My Queue screen reflects that she has moved up in the queue since someone ahead of her was served at Zinger Mints. If also wants to adjust her service time estimate, maybe tonight the deli's busier than usual, so parties are taking longer than normal, she can go to the My Settings tab and change the average service minutes per party input to reflect tonight's pace. As tonight progresses, Priya moves to the queue. Eventually, she gets to Shelly's position and admits her to the venue. On Shelly's end, she can see that she is no longer in the queue. That's Priya's full workflow: monitoring the queue roster, removing a guest manually, serving the next guest, and keeping her wait time estimates accurate throughout a busy night.
Now I'll talk a little bit about how we built this app. So our front end is built with React Native and TypeScript. So React Native lets us target both those iOS and Android users, which is important because this is a universal app. And specifically, we use TypeScript because they have type safety catches, so they catch a lot of our bugs at compile time. And this is especially useful for when users are passing data between components or calling our backend APIs. The main UI components we built for this app include the venue dashboard, which we are seeing right now, which uses TypeScript, and it includes a scrollable list of customers in the queue so that the venue can make more informed decisions about the party availability. And then our backend is built with Fast API in Python. So Fast API is a technology that both Anna and I were comfortable with, and the format of it was easy to allow us to create API documentation. And also Fast API handles concurrent requests efficiently, which does matter for if/when this app is used for a real-time queuing system. Our team also ended up using a pseudo-agile methodology in 2-week sprints to complete this project. It was really helpful that the weeklies and deadlines for assignments were approximately every 2 weeks throughout the semester, so that we were able to easily come up with the deliverables for each 2-week sprint. Our team also created a backend algorithm for calculating wait times that use queuing models. So our venue that we chose to create an actual wait time model for was M36, and we calculated it by taking 3 different samples of customers to determine the average wait time between when they got in line and when they received their orders. And the average time that we found for these interactions was around 112 seconds, which indicates that a user's wait time is the number of guests in front of them multiplied by 112, and that would be in seconds. And that was just one venue that we created a model for, but our team will hope to create similar models for Joe's Pizza and other venues before we look into deploying this app to a customer marketplace. And then finally, I also wanted to mention that we use GitHub to share code and create features for our apps simultaneously. And this was especially helpful since our team was split by front-end and back-end developers. So using GitHub version control really allowed us to work together more efficiently. And then moving on to our testing section, we wrote 10 total tests and we discovered a couple bugs during this phase. So we split our tests into 3 components. The first was we created a UI rendering test page, and we wrote one for each of our major screens, which include the home page, the venues page, and the My Queues page, and the venue dashboard. These tests verified that all components appeared in the right place and were able to be compatible with both full screen and split screen views. Our second category of tests followed a user all the way through how they would use this app, which included joining the queue, updating the queue statistics from the venue side, removing customers from the queue, and then also having the venue serve the next guest. And then our third category of tests focused on unit tests to make sure that navigation between the 3 main screens worked correctly, since a broken navigation bar would make the whole app kind of unusable regardless of how our backend was functioning. And I'll talk through some of our most interesting bugs that we found and how we resolved them. So the first one we found was a scrolling glitch on the homepage. We also witnessed this bug during our midpoint demo, but essentially when users scrolled down the homepage, it would randomly snap the user back to the top. And this was really disruptive to the core flow of our app, since joining a queue requires browsing the actual venue list. But luckily this was resolved when we redesigned the UI. And then the next bug that we found was a front-end inconsistency on the bottom navigation bar. So the home and venues tab showed a bold label and a black indicator line when that screen was selected, but the My Queue tab was missing those elements just like entirely, which meant that the user had no visual confirmation that they were on that screen. But this was an easy fix as we just applied the same styling as the other tabs, but it really reminded us to pay more close attention to detail. And then the last bug I wanted to cover was that our queue was not decrementing correctly at first. So when a venue served a guest, some customers weren't able to see their queue count update. And during debugging, this really seemed like random behavior, which made it even harder to track down. We wrote a couple of targeted tests against this behavior, and we found an edge case where when the venue was in the first position of the big list of queues, their queue count wasn't being updated on the customer side. And it seemed like this was random behavior because the first position venue changed every time we deployed the app. But we were finally able to fix this bug, so all the queues update correctly now, which is good. There were also some lower priority features we scoped out, but we didn't get to within the semester. If we were to roll out Next Step to real customers, we'd want to implement these before launch. First, we want to add push notifications. So right now, users have to manually check the app to make sure what their position is in the queue, but in reality, you'd want the app to be able to notify you when you're a few spots away from the front so that you can actually physically start heading over. And then the second thing that we wanted to implement was user authentication. So currently there's no login system from the customer side, so users are all identified as guests. But in a real version, we would hope that customers have accounts, which would also let us store queue history and preferences in our database. And then the third priority feature that we wanted to implement was a multi-venue support for customers. So right now, a customer can only be in one queue at a time, but if you're waiting for a table at a restaurant, you might also want to grab coffee at a nearby shop. So it'd be useful for them to be able to hold spots at multiple venues simultaneously, and then also be able to manage them all from one screen.
Great. Now I'll quickly talk about how to deploy next up. For local development, the setup is pretty straightforward. You can clone the repo from GitHub, install Python dependencies, and run the fast API server. For the front end, you can install Node dependencies with and start Expo to launch the React Native app in a simulator or on a physical device. The front end and back end are separate code bases that communicate over a local API. You point the front end at the back end URL, localhost during the development, or a hosted URL in production.
So where exactly would Next Up go if we were taking this to real customers? First, we want to figure out how we would host this site. So right now the backend runs locally, but to serve real users, we deploy the fast API backend to a cloud provider, and this would be something like AWS, and put it behind a proper domain for users to access. The database, which right now is local, would then also need to move to some sort of managed service, which again can be done through AWS. Secondly, we'd want to publish to the App Store. We built our front end in React Native specifically so we could target iOS. Publishing to the Apple App Store would require a developer program membership fee and would also require us to pass Apple's review process, which would take, months and months, which is very doable, but is also outside the scope of this semester, unfortunately. And then in lecture, we also spoke about how to expand into niche markets. So right now we're targeting restaurants and bars because that's where wait time is most familiar to us all. But the same infrastructure applies anywhere where capacity constraints create queues. So think urgent care clinics, DMVs, amusement parks, dining halls. And each one of these things is a niche market with slightly different needs. So that would require different queue models, different notification cadences, but the core system supports all of these things. Finally, we'd want to make our queuing model more robust. We've built the mathematical foundations for our wait time predictions, and right now those models are fairly simple, but with real usage data, we could build real machine learning-based prediction models that could pull from our historical data and get better over time. And this will allow for more accurate predictions and better handling of peak hours and also outlier detection that might happen for unusually long wait times. All in all, thank you for watching our demo of Next Step. This project's potential really excites us, and we truly hope that our virtual queuing options have the means to serve our target demographic in a meaningful way. Thank you once again.